Okay, so our instructions are going to be simplify the radical, give answer in simplified radical form, assume all variables are positive, so we don't have to worry about the absolute value. We don't want to just convert this to the rational exponent form and say that's simplified. It's not simplifying it by doing that. Okay, so this time I'm going to start with the number because I want to show you the pattern I go through. Well, 64. I want to break this down similar to what we did with prime factorization. I want to divide by perfect nth powers. So if there's a square root, I divide by perfect squares. If there's a cube root, I divide by perfect cubes. It's a fourth root. So I want to start with 2 to the fourth. So I always start with 2 to the index we have. If that's a 5, that's a 5. If that's a 6, that's a 6. Well, 2 to the fourth is 16. Well, 64 is actually 16 times 4. So I know that this is 2 to the fourth times 4. Well, normally I would go through and remember with the prime factorization tree, you divide by that value, you divide by 2, divide by 2, divide by 2 as many times. Well, I know that the lowest one I have here is 16. I mean, I could divide by 1 to the fourth. It's just 1. 16 is greater than 4. I'm not even going to go worry about trying to divide in. Okay? So I know I'm going to take out the 2. Now, we could break down these to match this using the product rule or the power rule. Here's a mechanism I've been teaching lately that some will like. Okay? Well, think about it if we did change this to a rational exponent form. Power over index. Power over index, that would really be s to the 38 over 4. That would be t to the 55 over 4. Again, that's what students will do, and they'll leave it like that. That's not simplified. Let me repeat that. That is not simplified. And it's not going to leave the answer in simplified radical form. But it is a step towards it. So if you do want to convert it, what I do want to do as a mechanism is I actually want to do a division here. I want to do the old school division. So I want to take, and I want to divide the numerator, in this case 38. I want to divide it by 4. Over here, this one black, this one's going to be still division by 4 into 55. Okay, so now usually I go through and I label, this is the S, this is the T. I label the variable. Okay, so let's go through and do the division. 4 goes into 38. Well, 4 doesn't go into 3, so 4 goes into 38. We say 9 times. 9 times 4 is 36. We have to remember that at this stage in this long division algorithm, that maybe haven't done in a while, we subtract here. 38 minus 36 is 2. That's as far as I need you to go. I need you to get to the first remainder. I don't need you to put a decimal place and all that. But doing this division on the calculator is not going to help you because this number is important and this number is important. 9 point whatever the decimal is going to be is not going to help you out. Over here, continue. 4 divided by 55. Well, 4 goes into 5 one time. Subtract 4. Drop down to 1. Drop down to 5. 4 goes into 15 3 times. 3 times 4 is 12. Subtract. 5 times 2 is 3. Okay? So here's what I want to tell you. I'm going to write my answer over here ultimately. The number that is here, the number in this position, I'm going to label it with a symbol because I didn't leave myself room and I just realized that. So I'm going to put a check mark. So the check mark is the exponent on the variable outside the radical. Check mark is the exponent on the variable outside the radical. So I will start the solution over here. I know that I'm going to take a 2 out. Well, I know I'm going to take an s out, and it's going to be s to the exponent on the variable outside. So we were working with the s here. This is the exponent on this variable, so s to the 9th. The t, we're taking information out. T to the 13th. It's the exponent on the variable outside. So when you do this division, whatever number we get up here is the exponent on the variable outside the radical. Well, that still leaves information inside, correct? Still a fourth root. That 4 is still inside. Well, here's the thing. Let's do this. I'm going to do an asterisk. Okay. So I'm going to have to erase some here because I know you're not going to be able to see that. So I'll erase the original. So the asterisk, those numbers, those remainders, are the exponent on the variable inside the radical. So anytime we get the remainder, we know there's going to be s, and I'm going to have 2 of them. There's going to be t, and I'm going to have 3 of them. So a general pattern, instead of taking, now maybe you do this as an intermediate step, change it to the rational exponent so know what you're dividing by, or what that division would be, and then do the actual division. Number here goes on the variable outside the radical. So 9 on s, 13 on t. This is on the exponent on the inside. So this is our simplified radical form. I know you're looking at it and saying, how is that simplified? Just remember, these could be formulas for complex items. As soon as you know what s and t are, it just becomes values that you calculate. Okay, so what I'm going to want you to do is maybe look at these processes again, breaking it down, product rule in reverse, breaking down through the power rule. I like that when the numbers are larger, or this is acceptable. Okay, so I want to give you one here, and I want you to try it. Whatever method, so this will be your first U try. Just in case you haven't gotten it. So U try number 1. Is cubed root of 54 x to the 9th (25th). Okay, so I want you to try cube root of 54 x to the 9th y to the 25th. Try simplifying it. Assume everything is positive. Whatever method you choose.